Good morning students, this is Latif sir. In this video I am going to start the chapter 4 of class 9 chemistry. The topic is atomic structure and chemical bonding. This is the chapter 4 of class 9 chemistry. Topic is atomic structure and chemical bonding. Okay, syllabus is given. You can see structure of an atom, mass number, atomic number, isotope octet rule, okay, definition of atom, constituent of an atom, nucleus, proton, neutrons, okay, all these are given. And electronic distribution, 2n square rule, this is the syllabus. And different types of bonds, covalent bond and electrovalent bonds, formation of electrovalent bonds, their definition, with example, covalent bond definition with example. This is the syllabus. Okay, so today today in this video I'll discuss about the introductory part of this chapter, that is the constituent of atoms, what is an atoms, okay, and atomic models. So atom is the smallest particle of an element. Atom is the smallest particle of an element, and according to Dalton theory, matter consists of very small individual particles, and these are called atoms. And atoms can neither be created nor be destroyed, according to Dalton theory. And Dalton told the atoms of an element are alike or same in all respect, but they differ from the atoms of other elements. And atoms of an element combine in small number to form molecules. Okay, and next point of Dalton atomic theory, atoms of an element combine with atoms of other elements in a simple ratio to form molecules of compounds. And last point, atoms are the smallest unit of matter that can take part in a chemical reaction. And some points of this atomic theory, some postulate of this Dalton atomic theory was correct, and some of the postulates were wrong. Okay. Here note is given: the latest research on atoms have proved that most of the postulates of Dalton theory are incorrect, except that atoms take part in chemical reaction. I have told that some maximum postulates are was wrong. Okay, so only this postulate, that is atoms can take part in chemical reaction, is correct. Okay, now see constituent of atoms. You have already studied in class 8. Atoms is composed of three type of subatomic particles: proton, neutron, and electron. In this chapter you have to remember what is the symbol of electron, and who discovered electron, who discovered proton, name of the experiment. As for short question, for short question you have to remember these points. Okay, like E. Goldstein discovered proton, James Chadwick discovered neutron, J.J. Thomson discovered electron. So this point you have to remember for short question. Now see definition of an element. What is element? Element is a pure substance that can neither be decomposed into nor formed from single substance by ordinary physical or chemical method. Definition of an atom: an atom is the smallest particle of an element that exhibit all the properties of that element, and it may or may not exist independently, but take part in every chemical reaction. Now the constituents of an atom. I have already told atom is composed of three types of subatomic particles: electron, protons, and neutrons. Electrons were discovered by J.J. Thomson using cathode ray experiment. Okay, J.J. Thomson finally discovered electron using cathode ray experiment. Okay. So what was the cathode ray experiment or discharge tube? It is discharge tube. A discharge tube, it is a hard glass tube fitted with two metal plates known as electrode, one of which is connected to the positive terminal of battery and is called anode. Anode is positive end, electrode, while the other electrode, which is composed of negative terminal of battery, is called cathode. Okay, and when electric current of 10,000 volt is passed through the gases in discharge tube at very low pressure, cathode rays are produced from the cathode and it will migrate towards anode. You can see cathode rays uh, are producing from cathode and they are migrating from cathode towards anode. Okay, so when electric discharge of 10,000 volt is passed through the discharge tube, uh, through the discharge tube in which some gases are there at very low pressure, 0.101 millimeter pressure, cathode rays are produced. Now see cathode properties of cathode rays. Some properties of cathode rays. See, the cathode rays travel from cathode to the anode in a straight line, and cathode rays, they cause a greenish yellow fluorescence on the soda glass screen placed in the tube. And cathode rays are affected by electric field, so they are inflated towards positive field. That means cathode rays carry negative charge particle. Okay, because they are attracted towards positive electric field. And when a beam of cathode ray is made to fall upon the metallic target like tungsten, X-ray are produced. And cathode rays can cause ionization of gas through which they pass, and the ratio of charge to mass of the particle constituting cathode rays remain the same, and the value of charge to mass ratio for cathode ray particles, the value is E by M ratio is 1.76 into 10 to the 11 coulomb per kg, irrespective of the nature of gas taken and the metal forming the electrode. Okay, so this was the characteristic of cathode rays. Now see the conclusion of J.J. Thomson cathode ray experiment. J.J. Thomson concluded that cathode rays consist of negatively charged particles and these are called electrons. Okay. Now see properties of electrons. Their electrons, they are a constituent part of all atoms. The mass of an electron is 1 by 1837 the mass of hydrogen atom. Okay, so mass of an electron is 9.1 into 10 to the minus 31 kg. Remember this value. Mass of an electron is 9.108 into 10 to the minus 31 kg. Charge of an electron is minus 1.602 into 10 to the minus 19 coulomb. Okay. Now see discovery of proton. Goldstein discovered proton using anode ray experiment. Okay, so Goldstein noticed another set of rays traveling in direction opposite to the cathode rays, that is from anode towards cathode, when a perforated cathode was used in the discharge tube experiment. And Goldstein he called these cathode rays, anode rays, as canal rays, since these rays pass through the holes or canal in the cathode. So anode rays was called as canal rays because These rays pass through the holes or canals in the cathode. Okay, these are also called positive rays or anode rays. Properties of anode rays. Some properties of anode rays are given here. You can see anode rays, they are like cathode rays. Anode rays also travel in a straight line. They consist of minute material particles, and they are made up of positively charged particles which are called protons. Okay. Positive rays deflected by electric field and magnetic field, but in a direction opposite to that of cathode rays. This means that these anode rays consist of positively charged particle, and these are called protons. And anode rays, they produce fluorescence on zinc sulfide screen, and the charge to mass ratio for anode rays differ from gas to gas. Now see, so anode rays consist of positively charged particles which are known as protons, and cathode rays are consist of negatively charged particles which are known as electrons. Cathode rays was discovered by Goldstein, and uh, electrons was discovered by J.J. Thomson, and protons was discovered by E. Goldstein. Okay. Next atomic model, pump pudding model of atom. J.J. Thomson proposed pump pudding model of an atom after discovery of electron and proton. According to the pump pudding model, this model was not accepted actually. So according to pump pudding model, an atom is considered to be a sphere of uniform positive charge, and the electrons are embedded into it, and the total positive charge is equal to the total negative charge, so that an atom as a whole is electrically neutral, and the mass of an atom is considered to be uniformly distributed. This was the pump pudding model, but this model was discarded later. Okay, and now see discovery of nucleus. Rutherford discovered nucleus using his alpha particle scattering experiment on gold foil. Okay, so alpha particle scattering experiment. Scientist Rutherford, he selected a gold foil because he wanted as thin a layer as possible, and gold is the most malleable metal, and using gold you can make a very thin layer as you can make very thin layer of gold. Okay, and in the alpha particle scattering experiment of Rutherford, he observed that most of the alpha particle pass straight through the gold foil, very thin gold foil, and some alpha particles were slightly deflected from their straight path, and very few, nearly 1 in 10,000 alpha particles were either deflected by very large angle or completely bounced back. Okay, this picture showing the alpha particle scattering experiment of Rutherford, and later Rutherford generalized these results of alpha particle scattering experiment, and he suggested a model which is known as Rutherford atomic model based on alpha particle experiment. One note is given: heavy metals such as platinum will show the same observation with alpha particles as shown by gold, but if light nuclei like lithium is used, then fast moving alpha particles may push the light nucleus aside and may not be deflected back. Okay, so you have to take gold foil, heavy metal like gold or platinum, in Rutherford alpha particle scattering experiment. Now see Rutherford atomic model. According to Rutherford atomic model, The protons are present at the center of an atom, which is known as nucleus, and electrons are revolving around the nucleus in different circular path, and these are called orbits. These are called orbits. Okay, so electrons revolve around the nucleus. Electrons revolving around the nucleus in closed circular path, these are called orbit, and protons are present at the center of the atom, which is known as nucleus. This is the atomic model of Rutherford, and maximum space in an atom is empty. Okay, so electron revolving around the nucleus at large distance from each other and from the nucleus. And an atom, according to Rutherford atomic model, an atom as a whole is electrically neutral. This is because the total positive charge in the nucleus is balanced by the total negative charge of the electrons. That is, the number of protons and number of electrons in an atom are equal. And Rutherford atomic model is similar to the structure of solar system, in which sun is present at the center of the solar system and different planets revolving around the sun. Similarly in an atom, the nucleus contains the main mass and the electrons revolving around the nucleus in orbit or shell. Now see drawback of Rutherford atomic model. Drawback of Rutherford atomic model. The main drawback of Rutherford atomic model, according to classical law of mechanics and electrodynamics, if an electrically charged particle is in motion, it continuously radiate energy. It will radiate energy, and thus an electron, when moving around the nucleus, the electron should radiate energy. That is, the electron loses energy. As a result, it should be gradually pulled towards the nucleus and end up colliding with the nucleus, and this should result in the total collapse of the atom. This is the Rutherford drawback of Rutherford atomic model. Okay, so when an electron will revolve around the nucleus, it will radiate energy and it will lose energy, and its diameter of the circular path will continuously decrease, and finally the electron will collapse with the nucleus. So Rutherford atomic model cannot tell about the stability, cannot explain the stability of an atom. Okay, this is the main drawback of Rutherford atomic model. Later Niels Bohr gave the Bohr atomic model in 1913. Niels Bohr, a Danish physicist, explained the cause of the stability of an atom, and he gave the atomic model. According to Niels Bohr atomic model, main postulates are: the electrons revolving around the nucleus are confined to certain fixed orbit. Electrons revolving around the nucleus are confined to certain fixed orbit, and this fixed orbit are called shell or energy level, and each of which is associated with fixed number of energy. Second point, while revolving around the nucleus of an atom in an orbit, the electron neither loses or gain energy. According to Bohr atomic theory, while electron is revolving around the nucleus in an orbit, an electron neither loses nor gains energy. And an electron revolving in a particular orbit, on gaining a certain amount of energy, it will jump to the next orbit or vice versa. Since each orbit is associated with fixed amount of energy, Bohr called this orbit as energy level, and Niels Bohr said that the electrons are revolving in around the nucleus in different circular path, and this circular path or energy level was designated as K cell, M cell, N, K L, M, N. Okay, these are energy levels around nucleus. Electrons are revolving around a nucleus in different cell, K cell, L cell. The first cell is K cell, second cell is L cell, third cell is M cell. Okay, so this is the Rutherford atomic model. And now discovery of neutrons. Neutrons were discovered by Chadwick. Neutrons was discovered by Chadwick by bombardment of beryllium plate by helium particles. Okay, Chadwick discovered neutron particles by bombarding light nuclei like beryllium with alpha particles, that is helium nuclei. And neutron is neutral particle, and it is denoted by 0 n 1, and mass of neutron is equal to 1.676 into 10 to the minus 24 gram, and charge is 0. Neutron is neutral particles. Okay, thank you students.